Hi, my name is Cademan Brady, and today I'll be talking about the annealing of steels. The objectives of this presentation is to compare and contrast the many different types of annealing and to discuss their effects on microstructure. We will also discuss the properties associated with treatments and applications in industry. Annealing is similar to normalizing in that it heats the steel to a very high temperature and has three stages: recovery, recrystallization, and regrowth. However, unlike normalizing, it has a very slow cooling rate, also called furnace cooling. On the right, we have a carbon steel phase diagram. It's important to note the A3 line, which is the austenite line for hypoeutectoid steels, the eutectoid temperature, which is around 727 degrees Celsius, and the eutectoid point, which is around 0.76% carbon. The first type of annealing I want to talk about is process annealing. Process annealing happens at the lowest temperature of annealing, around 550 degrees Celsius to 700 degrees Celsius, and is best suited for low carbon steels, also known as hypoeutectoid steels. This type of anneal is mainly used after cold working to negate some undesirable properties caused by cold working. This is mainly done by increasing the ductility of a sample. On the top right, we can see that a sample that is being cold worked. When a sample is cold worked, the grains become fine and elongated. These grains also have internal stresses. These factors cause the sample to be very hard, however very brittle. When a cold worked material is process annealed, it goes through the first two phases, recovery and recrystallization. In the recovery phase, the stresses of the cold worked grains are relieved, and in the recrystallization phase, new unstressed grains start to nucleate and form. The second type of anneal is a full anneal. This is a higher temperature than process annealing and leads to a much softer microstructure, normally coarse perlite. This softer microstructure also leads to more ductility, increased machinability, and improved electrical and magnetic properties. On the right, we can see a metallograph of coarse perlite. The dark black regions are a ferrite matrix, and the white are stacked cementite sheets. A common application of full annealing is softening ductile pipe after it is cast. The final type of annealing I want to talk about is spheroidizing anneal. This happens at a lower temperature than full annealing, just below the eutectoid temperature. It's comprised of a ferrite matrix with dispersed cementite spheres. These spheres form after the cementite sheets are dissolved and then reformed into the cementite spheres. This type of anneal yields the softest steel. This soft steel is very ductile and very machinable. A common application of spheroidizing anneal is used during the manufacturing of railroad tracks so that they can be machined and bent to shape before they are processed more. In conclusion, annealing is a very important heat treatment. There are several types with varying temperatures. The type of anneal used is dependent on the steel and the purpose of the steel. And as we saw, annealing has many applications in industry. Thank you.